guys, Miss Zimmer here with Radicals Part 2. We only have 2 more lessons to go. Now, yesterday I was showing you simplifying. So if you had the square root of 50, you would split that into the square root of 25 times the square root of 2. And since this is a perfect square, you would get 5 root 2. We said you could have a negative in front of that radical and get negative 5 root 2, but you cannot have a negative under a perfect square. If the index number, which the index here is a 2, a square, if the index number is even, you cannot have a negative number, so it is not a real number. So not real. All right, let's move on to radical part 2. So we're going to continue with some of these simplifying. Here's an example, negative 4 square root of 175. The negative sign is in the front, so we will keep it. Keep the 4 in the front, break down the 175. 25 is a perfect square and goes into that. So square root of 25 times 7, square root of 7. This is a 5. And we multiply those two together. Negative 20 root 7. Done. So that is another type of problem that we saw last time. And now we're going to move on to cubes. So what if we had the cube root of 54? Well, our cubes, we have several cubes. We have 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. Best thing to do is have your cubes written down, maybe a few to the power of 4, but definitely these cubes. Now, what goes into 54? 27 goes into 54 2 times. So this breaks down into a cube root of 27 times a cube root of 2, because 27 times 2. So if one of these numbers goes into this root, we take it out, we say what's left over, and excuse me, this is a cube root as well. They're still cube roots. So the cube root of 27 we know would be 3. 2 does not have a cube root, so it stays right where it is. Doing another one, the cube root of 18. Well, does 8 go into 18? No. 24? No, and it's too high. So the cube root of 18 is just the cube root of 18. And you might be thinking, well, 2 goes in. 2 is not one of these 4 numbers. 3 goes in. 3 is not one of these numbers. 6 goes in, and 9 goes in. Well, 9 is a perfect square. It is not a perfect cube root. So only these numbers, if they would go in there, and of course, 5 to the 3rd, it keeps getting higher, not lower. So if one of these doesn't go into 18, if 8 didn't go in, nothing will. Here's another one. Yesterday we saw fractions under a radical sign, and we said you could split it up. So that's what we're going to do. Split it into cube root at the top and a cube root at the bottom. Well, this is a cube, perfect cube. 2 cubed is 8. So the cube root of 8 is 2. The cube root of 7, it doesn't have a cube root, so we leave it alone. Sometimes in this section, knowing what not to change is as important as what you can change. Here's another cube root of 40 over 27. So cube root of 40, cube root of 27. 27 is a number on our list, so we can automatically say the cube root of 27 is 3. 40 is not on this list, but 8 goes into 40, so the cube root of 8 times the cube root of 5. The cube root of 8 is 2. So we get our final answer, 2 cube root of 5 over 3. So you look at that and you look at that and you go, well, it doesn't look like that's really simplified. And the answer is to simplify. It is simply because it does not have a radical in the denominator, and that's one of the goals of simplifying, or what we call rationalizing a number. And we'll see more of that later on. All right, what if the numbers get a little bigger? Well, they're going to if we're dealing with cubes. So in our notes, if you happen to print up the notes or be following along, what if we have a 4th root? Well, at that point, in a 4th root, we might just try out our calculator. Yesterday I showed you would hit 4. Make sure the calculator's on, I guess. We would hit 4, and we would hit second and the up arrow button, which gives us the little x in front of the radical sign, and 243. Let's see if it's a cube root. It is not. It's a decimal. So let's check out some of our 4th roots and see if one will go into 243. So that's our first line of defense. Well, what is 2 to the 4th? 2 to the 4th is 16. What is 3 to the 4th? 3 to the 4th is 81. And 4 to the 4th is 256. You can notice it jumps up really fast when you're doing fourths. Well, are any of these, is 243 divisible by 16? Let's check it out. No. Is 243 divisible by 81? Yes, it is. So that means the 4th root of 81, this 4th root, times, well, 81 went in 3 times, so the 4th root of 3 is left. So 81 times 3 is 243. The 4th root here would be the number 3, and then we have the 4th root of 3. So that would give us our answer. Okay. Next one up, very similar to this. Let's do the 4th root of 3 over 16. 4th root of 3 over 4th root of 16, break it up. The 4th root of 3, sorry, that looks like 4 root 3. 4th root of 3 is 4th root of 3. There is no 4th root of 3, but there is a 4th root of 16. That would be 2. And that's an index number, so nothing will cancel with that. Next one, a 5th root. You're like, what? How far are we going to go? That's as far as you'll see, at least in Algebra 1. And that will be kind of an unusual occurrence. Let's try this out. 5th root of 64. Well, 2 to the 5th, we just said 2 to the 4th was 16, so this would be 32. Oh, that's 2 times 32. 3 to the 5th root, by the way, 3 to the 5th root would be up at 243, so way too high. So if this number doesn't go in, then we can't break it down. Oh, we can. 5th root of 32 times the 5th root of 2, because 32 times 2 is 64, and the 5th root of 32 is 2, 5th root of 2. Done. There's our answer for the 5th root of 64, simplified. Moving on. You'll be happy to know the next section, which is adding and subtracting, is a lot like something you've already learned. Well, if I said add x plus x, you'd say no problem, that's 2x. If I said add x plus y, you'd say those aren't like terms. So the answer would be x plus y. Or if we had 3x minus x, you might subtract those coefficients and get a 2x. Well, we're going to do something very similar, but we're going to use radicals. So instead of x and x, we're going to have the square root of 3, square root of 3. That would equal 2 root 3. There's 1 here, there's 1 here, and we treat the root 3 very much like that x value, that x variable. We just put it together. And we keep it, when we put it together, put the coefficients together, we keep the radical the same, just like we kept the x value the same. We didn't change exponents, we didn't multiply it together, we just added the coefficients. So here, what if we had the square root of 3 and the square root of 5? Could we add those coefficients? No, because very much like x and y, these are not alike. So we would not be able to add those together. And then if we went back to root 3, just like the one up here, we would add, or in this case, subtract the coefficients, 3 minus 1, and we would keep the radical exactly the same. So we can treat our radicals just like we treated our x's and y's, our variables in equations and expressions. So if we have 4 root 5 plus 3 root 5, yes, we would add the coefficient or the number in front of our radical and then the square root of 5. Okay. So we have like radicals just like we have like variables. All right, next one up. Root 10 minus 6 root 10. This is a 1, so 1 minus 6, negative 5 root 10. Next, what if we have cubes? Well, they still have to be alike. These are the same root. They have to have the same index and root. So we would add one of these to one of these, and we'd have 2 cube root of 7 minus 4 cube root of 5. Just because their index is the same doesn't mean we can put them together, because our radical, one is 7 and one is 5. So they have to have the same index number. These were all perfect squares, so they had the same index number. Next one. So what if we had 2 root 6 plus 2 cube root of 6? Do they have the same index number? No, they don't, because this would be a square and this one would be a cube. So we would just write 2 root 6 plus 2 cube root of 6, and we'd be done. Why don't we just leave it blank? Because then we wouldn't have an answer. We can't write all real numbers. We can't write, because this is exactly the answer. It's already been simplified. So there are no like terms to combine. Now, we're going to look at some that look like they don't have like terms, but there's a catch. Notice these can't be simplified, these radicals, because 6, there's no perfect cube or square or cube that will go into them. We're now going to have some radicals that when we add or subtract them can be simplified first. So here's our first example of that. As they are, we cannot add the square root of 50 and square root of 8 together because they do not have the same number underneath our radical. The radicands are different. So what we're going to look at is the fact that the square root of 50, that's not a simplified number. So recall that this can be broken down into the square root of 25 times the square root of 2. And the square root of 8 can also be broken down because perfect square of 4 goes into that. Remembering our perfect squares, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. We're looking at those perfect squares. So we have 5 root 2 here plus 2 root 2 here. So it looked like these numbers did not have a common root. but they do have a common root once they're simplified. So our answer would be 7 root 2. Moving to another one similar to this. Let me go ahead. 7 root 12 minus 75. Well, 7 root 12 can be broken down into 7 root 4 times root 3. 75 is the square root of 25 times root 2, right, root 3. 4 is a 2. The square root of 4 is 2. The square root of 5 is 5. 7 times 2 is 14, root 3. 5 root 3. And now those do have the same radical. 14 minus 5 is 9 root 3. Same radical. Excuse me for 1 second, I'm losing some power. I need to plug in my computer and then I will continue. Just pause for a moment. All right, sorry about that. I usually have my computer plugged in just in case, but I forgot this time. So let's continue as soon as I get this plug in the right spot. Excuse me. Now that I'm not going to lose power, we'll continue. All right, so next one up. Some of the problems will have more than 2 radicals to try to combine those like terms with those like radicals, such as the square root of 25. Sorry, I must have put down my good marker. Let's try this one. Square root of 25 minus the square root of 27 minus 2 root 18 minus the square root of 16. Well, 2 of these are perfect squares, so we'll go ahead and change those right away. And we'll simplify the others. The square root of 25 is 5 minus, well, 27 is not a perfect square, but 9 goes into it. 9 goes in 3 times. 18 is not a perfect square, but 9 goes into it twice. And 16 is a perfect square. So right now we've got a 3 here and a 3 here for those perfect squares. So we have 5 minus 3 root 3 minus 2 times 3 is 6 root 2 minus 4. Well, we can look at the 5 and the 4. Those are alike. 5 minus 4 is 1. Negative 3 minus 6 is negative 9. Oops, excuse me. My apologies, they're not the same radical. So minus 3 root 3 minus 6 root, and you know what? Yeah, root 2. There we go. I just want to make sure I had it all in there. Now, the order does not matter. So if you put it in a slightly different order, it's fine. Okay. If you decide to put the 1 at the back, or the root negative 3 root 3 minus 6 root 2 plus 1, that would be perfectly fine. Just make sure you have your signs correct on each one. Okay, let's look at a couple more of these, and then we'll be finished with adding and subtracting radicals. And our last lesson will be multiplying and dividing them. All right, so our next one up, let's include some variables. Now, recall the last rule that we went over on Radicals Part 1 that says you need to divide the exponent by the index number. The index number here would be 2, the index number here would be 2, and this one would be 2. So when we simplify this one, x2 divided by 2, that would give us an x to the 1, first power. But here, 5 divided by 2 only goes in twice. There's still one x left over. So consider this. The square root of 25 is 5, but if you have 1, 2, 3, 4, 5 x's, you've got one pair, 2 pairs, so that's why we have an x squared, but one of those is going to stay underneath the radical sign because it doesn't have a matching pair. That's why we divide it by 2, and we have 1 remaining. Here we also have x squared and 1 remaining x value. So 5 goes in twice with a remainder of 1. So remember our old long division goes in twice. 2 times 2 is 4, remainder of 1. Square, remainder. All right, now we do have some radicals that have the same radical behind them. These two, so we have 2x. We can add the negative 5 and the positive 1 minus 4x squared root x. And then we're finished with that one. All right, let's do one more of these, and then we'll look at another one with some cubes. And now, just when you get comfortable with the squares, we can move to the cubes. X to the third minus 8x square root of x plus 3 square root of x. So these all have an index number of 2. They're all square roots. So 3 divided by 2 goes in once, and 1 left over for underneath the radical. Minus 8. Well, there is no square root of x, so that will stay exactly where it is. And then the square root of x is x, so we have 3x. These can be combined because we have 1x here and negative 8x, so negative 7x, square root of x, plus 3x. Well, we do have an x here and an x here, but this one does not have a radical. If it doesn't have a root x, we don't have the same radical. We cannot combine those terms. They have to have like radicals, just like combining like terms, they would have to have like radicals to be combined. All right, let's do this with a couple of cubes, just for funsies here. All right, 5 cube root of 16x cubed minus cube root of 54x cubed. Keeping in mind our cubes, 2 cubed is 8, 3 cubed is 27, 4 cubed, 256, I do believe. Yes. I forget my cubes sometimes. Okay. Oh, sorry. I got carried away. That's 4 to the 4th. 4 cubed is 64. Just double checking. Yes. Okay. So just a few cubes to throw out there because you can already see this can be simplified. The cube root of 16. We've got an 8 here, so we've got 5 in the front. Cube root of 8. Cube root of 2. 8 times 2 is 16. Now, x to the third divided by 3 gives us x to the first. So we're going to put that in the front with this 5. We don't want to put it over here because we may think it goes underneath that radical. It no longer goes under the radical. Here we have a cube root of 54 27 times 2 is 54. So a cube root of 27 times a cube root of 2 and x to the third divided by 3, that gives us an x here as well that is no longer under the radical. Because if we have a cube root of x to the 3, that's x to the 3 divided by 3, just to remind you of that. And that's why we have our x to the first on the outside. And be careful, this is our index number. Sometimes when you get those numbers floating around, you may think I was doing x cubed, but I'm not. That's our index. Now we still have to solve this. We need our cube root here of 2, our cube root here of 3. So 5 times 2, we've got 10x cube root of 2 minus 3x cube root of 2. Since everything is the same, they both have a cube root of 2, they both have x. We can go ahead, their coefficients, 10 minus 3, 7x cube root of 2, our final answer. Fun stuff, right? Okay, I know you want to do another one of those before we wrap it up, so let's do that. For cube root of 81 x to the 6th minus cube root of 24x to the 6th. All right, we can already see we've got x to the 6th, and if we divide that by our index number in both cases, we end up with x squared. So now you'll see when I run into those x's what I got. Now, so we'll start with 4, 81. Well, let's check it out. What number goes into 81? 27 goes into 81 3 times. Okay. Just so that, yep, helpful. 27 times 3 is 81. So cube root of 27, cube root of 3, and then we have an x squared. I just showed you that x to the 6th divided by 3 is x squared. So minus, we know we're going to have another x squared. Cube root, well, 24. 24 is divisible by 8. So we want cube root of 8 times the cube root of 3. Well, cube root of 27 is 3. Cube root of 8 is 2. So we have a 4. 4 times 3, or 12, x squared, cube root of 3, minus x of 2. Excuse me, I almost forgot my 2 up here. 2 x squared, cube root of 3. And now the cube root is the same, the x squared is the same, so 12 minus 2 is 10. X squared, cube root of 3. So all those variables and radicals behind that coefficient have to be the same to be able to add or subtract those like variables and coefficients. All right, we're finished with part 2. Good luck.